So, looking at similar solids. Now, last time when we did this, all of this comes from that scale factor. So, when we did two shapes that had a scale factor, we always wrote that as like A over B. That was our scale factor. The length of this side compared to the length of that side. A over B. So let's make that some numbers. How about the numbers 1 over 2? So generally it's just A over B, and I'm making those numbers 1 over 2. Now how do we change this ratio of lengths to a ratio of areas?
Square.
We square it. So a ratio of areas is A squared over B squared. So if the ratio of areas is A squared over B squared, we have to square 1 over 2. 1 times 1 is 1. And 2 squared is 4. That's what we've already learned. We've already done this. And the new thing today, a ratio of volumes. So a ratio of volumes is going to be A cubed over B cubed. So instead of doing 1 squared, we have to always go back to our original scale factor. What is 1 to the third power? 1 times 1 times 1. 1. And then 2 to the third power, or 2 times 2 times 2 is 8. Right? So you can kind of see, like, as we get farther and farther into the dimensional analysis, the numbers get bigger and bigger and bigger. So these are the 3 things that you need today, and nothing else beyond this. We're going to be working forwards to get volume, or we're going to be working backwards to get a scale factor. Nothing super crazy. So let's look at this box here. I want to figure out what are those 3 proportions for these 2 related solids. The first thing you need is a scale factor. And you have to make the most important decision. Big over small, or small over big. Small over big. So pick a small length and its corresponding big length. 2 over 3. So this is now known as our scale factor. If I do 2 and 3, that means they have a 2/3 relationship. Alright? Because 8 over 12 simplifies down to 2/3, and 4 over 6 simplifies down to 2/3. So what is our ratio of lengths? Or a ratio of perimeters. Do I change the number? So our ratio of lengths is the same thing. That's just A over B. The ratio of lengths is the same thing as our scale factor. Now, our ratio of areas, A squared over B squared, because area is always like square centimeters. So to find a ratio of areas, I do squared. 2 squared and 3 squared. So we always go back, like this is 2 to the first power to the second power. What is our ratio of volumes? It's cubed. So I have to do 2 to the third power. 2 times 2 is 4 times 2 is 8. And 3 to the third power. 27. Now, if we're having trouble manipulating those things, please use your calculator. So, I have a number, a scale factor, 2 over 3. If I want to change that to a ratio of areas, I have to square it. And there it is, 4 over 9. That's my ratio of areas. If I have a scale factor of 2 over 3, and I want to make it volumes, I have to cube it. And there it is, 8 over 27. So your calculator will do this for you. Now, once I have these proportions, I can solve for a missing volume, a missing surface area, or a missing side length. Okay, here we go. Couple of parts here. It says these two pyramids are similar. They have a volume of 216 cubic inches and a volume of 125 cubic inches. So I'm going to write that down. The big pyramid has a volume of 216 cubic inches. The small pyramid has a volume of 125 cubic inches. The surface area of the big pyramid is 250. I'm looking for the surface area of the small pyramid. Okay, what do we have? We have two volumes. So right now, I know how you want to do big over small or small over big? Big over small. 216 is the volume of the big pyramid. 125 is the volume of the small pyramid. Okay? This proportion is a ratio of volumes, A cubed over B cubed. Now I want a ratio of surface areas. What is a ratio of surface areas? Is it A cubed over B cubed, A squared over B squared, or just A over B? A over B is lengths. That's the first box on your paper. So what is a ratio of areas? A squared over B squared. So I need to take this, and I have to make it A squared over B squared. Now, unfortunately, the only way to do that is to change this to A over B first to find the scale factor, and then to take the scale factor and make it a ratio of areas. So we have to, how do you undo cubed? The cube root. So in my calculator, I want to undo cubed. And I want to uncube the fraction 216 over 125. I want to undo that. And it's going to return 6 over 5. Yes, sir.
Oh, sorry if I interrupted.
No.
How do you do the square cubed?
Control, caret.
Okay. Okay, thank
Control, caret. So what happened here, the scale factor from those two shapes is 6 to 5. But is that a ratio of areas? 6 to 5 is just A over B. And what do I really want? Areas. So what do I have to do to 6 over 5 to make it a ratio of surface areas? Square it. Square it. So to change this to a ratio of areas, I got 6 squared is 36, 5 squared is 25. Right, that's a lot of stuff going on right there, isn't it? I squared it. So here's what happened. On this problem, they started with this, A cubed over B cubed. And we had to go all the way back to A over B so that I could get to A squared over B squared. There's no way to go from here to here. No. You can't undo squared and undo cubed and get squared. You have to go all the way back. It's not fair. There is a way to do it, but y'all, it's way beyond the scope of geometry. So, look, after all of that work, now we have a ratio of areas. So I know that the proportion 36 over 25 compares the areas of those two figures. Well, what is the surface area of the big shape? What's the surface area of the big shape? 250. And we're looking for the surface area of the small shape. So we get back to bat and ball, the butterfly method, you cross multiply and solve for x. So 250 times 25, 6,250. 36 times x. To get x by itself, you divide both sides by 36. So I'll take this number, 6,250, and divide it by 36. You get 173-ish. So the surface area of the small shape is 173. Holy Moses, right? That's a lot of mathematics. So that is everything that you're expected to do, all in one problem. So we're going to go back now. We're going to do this in small little pieces. Okay? Small little pieces. So here's the first one. You have two cylinders that have volumes of 200 pi and 25 pi. I want to know what is the scale factor. So what is the proportion that compares volumes? Is it a over b, a squared over b squared, or a cubed over b cubed? So right now I have this. And then you get to pick big over small or small over big. It doesn't really matter. Small over big. So I have 25 pi cubic inches, and I have 200 pi cubic inches. So I want a scale factor, and a scale factor is just A over B. Everything has to go from the scale factor forward. So how do I undo cubed? Cube root. So I have to do the cube root of this and the cube root of all of that. And your calculator will do that for you. Control caret. And you want to undo the cube root. Inside that, you want to undo the cube root of 25 pi over 200 pi. And then you hit enter and you pray to Jesus that it's a nice number, right? 0.5. Is that a fraction? Is that what we don't... What do we do now? You can do menu, it's a number, and you want to make it a fraction. 1/2. Menu 2. Menu 2. So now I know after I cube root that number, I get the fraction 1/2. And then you're done. Because all it wants is the scale factor. That's it. You have to always go back to the scale factor before you can go forward. Okay? So I'm giving you these things and asking you to go find the scale factor. If I wanted to do a ratio of areas, it would be 1/4. If I wanted to do a ratio of volumes, it would be 1/8. So you can go forward from there. I'm not asking you guys to do that. I'm just looking for what is the scale factor. So let's try it again. All right, you have two cylinders that have surface areas of 45 pi and 20 pi. So what is the ratio that describes surface areas? A squared over B squared. And the areas they gave us to compare are 45 pi and 20 pi. And yes, you do have to put the pi in there when you calculate it. So how do you undo squared? You take the square root of both sides. And that should leave us with just a over b. And that's what we want, just the straight up scale factor. So the square root of the fraction 45 pi over 20 pi. And then you cross your fingers, hope you get a nice number. What do we do? How do we make that a fraction? Menu, 2, 2. Make it a fraction, please. Okay, it's 3 over 2. That's the fraction. The fraction's 3 over 2. And then you're done. Your scale factor is 3 over 2. That's not bad. And then here's the last layer. So now that we're kind of comfortable finding the scale factor, we're going to go find the scale factor. Then we're going to work forward and solve for a missing dimension. Oh, still finding scale factors. Sorry, I got ahead of myself. Are these two shapes similar? Are they related to each other? How do you know? So you're using that term double, right? If I do radius over radius, it should be the exact same thing as height over height. Those proportions should be the same. So you can simplify this to 1/2. And you can simplify this to 1/2. What do you call these things in the box? That's your scale factor. Right? The baby cone is half as big as the daddy cone. Or the daddy cone's 2 times as big as the baby cone. That's your scale factor. And are the scale factors the same? Yes. So those two shapes are similar. Now what about this one? Are these shapes related? Uh-huh. You have to take all the parts of these shapes and compare them. Height over height.
It's not related.
Width over width. Depth over depth. Are all of those the same fraction? Well, this one simplifies down to 3 over 5. That one is 3 over 5. And this one simplifies down to, are all the scale factors the same? No, so those shapes are not related. Not related. Not related. And then here we go. All right, last 2 questions here. Don't scoff, it's just math. It says, you have the surface area of 2 figures. Please find the volume of the missing figure. All right, so right now they give us 2 surface areas. What is their ratio that describes surface areas? A squared over B squared. And you can pick which one goes on top. Small over big. So how do you undo squared? The square root of both sides. So let's go check the calculator. The square root of the fraction 16 over 100. Nice. 2 over 5. What? Yeah, 2 over 5. Sorry. 2 over 5. No. That's just your scale factor. What am I trying to solve for? a volume. So I have to cube that. I need an A cubed over B cubed. But guess what, guys? Since it's already in my calculator like that, I can just do, hey, please cube that. 18A over 125. So you can cube it while it's in your calculator. So now that we've calculated that their volume ratio is 8 over 125, we're able to put this number in its correct location. The volume of the larger is given. So is this the big one or the small one? This is the big one. It is asking us to find the volume of the small one. So the bigger number goes on the bottom. So this is our ratio of volumes, and these are the two volumes that we're trying to figure out. So we cross multiply. X times 125 is 125x. 8 times 500 is 4,000. And we divide both sides by 125. $4,000 divided by 125. 32. So the volume of the smaller figure is 32 centimeters cubed. Crazy, right? So you have to go backwards to get your scale factor. We took this ratio of areas and got a scale factor. We took that scale factor and cubed it to get a ratio of volumes. Then we used the ratio of volumes to find the missing piece. So there's like only a couple steps where you can't screw up and you're guaranteed to get the right answer, right? We're a complicated process. Let's try the last one. Oh, guess what? There should be one more in there somewhere. Oh, that's it. Remember this guy? Do you? So F plus B equals E plus 2. On your test, it's going to give you a sentence like this, and it's going to ask you to solve the equation. It says you have 10 faces. Where does that go? F. 11 vertices. Where does that go? And it's asking you to solve for E. What's 10 plus 11? Is that going to scare you? So there's one of those on there. And just remember in the formula 5 plus 2. Okay. So on your assignment, these are the 2 questions or 4 questions that I want. 4, 5, 6, and 7. And one, I think 2 of them are just identify the scale factor, and I think 2 of them are actually. No, it's actually do it all. No, it's just find the scale factor. That's all you gotta do. 4, 5, 6, and 7. Take the ratio it gives you and go back and find the scale factor. That was just like these problems right here. Right? 4, 5, 6, and 7. 4 questions. And then you have 2 assignments that I want today, right? These 2, the one I gave you on Monday, or the one I gave you on Tuesday, and the one I gave you on Wednesday. I was asking for you guys to turn those in today on Friday. If you get done with this 4 questions in the next 20 minutes, you can turn that in as well. Just